There you go.
Cool. So, folks, welcome to this conversation today. The you can see the title on the screen. I decided to put this title, "A Narcissist Ego Trip," in first because it's kind of weird for us to for you to talk about yourself. It feels selfish somehow. But the inspiration was in the skip levels I did last week. I was discussing with people in my division about career, leadership, and projects. And a bunch of people manifested interest in analyzing career options. Other people revealed some discomfort towards the pace of change, disruption, what's going to happen. And I realized that some people don't ask me questions sometimes because they don't know the things I've done. So maybe if I can share more about myself and stuff that I did in the past, I can give opportunity for people to come to me and discuss about it. And then I can share my experiences with them. So it felt less selfish. So I decided to do this anyway, as well as it was very convenient to use stuff that I did in the past. So I could assemble a presentation faster. And we're going through a moment in time that I've been before, not necessarily in the same proportions. I think AI may be the biggest disruption I've seen in my career so far, but there were other moments that things changed pretty fast. So maybe we can talk a little bit about these moments as well, and maybe seeing that we can survive through them can reassure you that we all will survive through what's happening right now as well. Okay, so I started this as a timeline. So there will be like dates and slides in chronological order with a few exceptions there. But again, feel free to interrupt me if you have a question, a comment, or anything of the sort. I look forward to it. So I start in 1986. Maybe many of you were not alive at that time, or very young at that time. I was about 13 in 1986. And I started my journey into computing first with this computer on the left in a course. So I didn't own a TK-85. I simply enrolled in a course. At the time, I was living in the northeast region of Brazil, in Fortaleza, Ceará. And I wanted a computer. And my parents said, if you want a computer, you really need to do some courses and prove that you're really into it because it's expensive. So I said, okay, cool. So I did courses. It was funny because the very first course, it was called in Portuguese, Básico do Basic, which in English means basic of basic, which I think is kind of funny. And I did 6 months of course in basic, and I proved to my parents that I was committed to computing. And they gave me this computer on the right, which was called at the time Expert, from a company called Gradient. Just for you guys to have a notion of what Expert was, it was based on the Z-Log Z80 processor CPU, which is a 3.58 megahertz CPU with just 8-bit instructions. It was binary compatible with Intel 8080, which was another very popular computer. It had 64 kilobytes of RAM with 32 kilobytes of ROM, read-only memory, where it had a resident basic interpreter. So when you booted the machine, you booted into the basic interpreter. It costs at the time the equivalent to $470, but bringing that up to today's currency, it would cost about $1,400, $1,400, something like that. And it took me some years before I could purchase the other gadget on the right, which is this data recorder here, which is not a cassette recorder for music. It's a cassette recorder for data. So you put a magnetic tape there, and then you had a screwdriver where you could calibrate the angle in which the reading head was reading the tape. So depending on the angle, each cassette recorder may have a slightly different angle. And if the angle was different, you may record in one cassette recorder and never read it again anywhere else. But with the power of calibrating the angle, then you can always read it. And the way to calibrate is by sound. So I started to read the data, and I put the tiny screwdriver on this tiny little hole here. Can you guys see my mouse? Cool. So we put the screwdriver in this tiny little hole, and then you can hear if it's a very acute sound, then it's perfectly aligned. You rewind the tape, and then you try to read it again, and then you're successful. The other very important thing is this counter on the top, because in a single tape, we had multiple programs recorded. So you need to forward or rewind to a position, to an offset in the tape, so that you can read the program that's where the program starts. So you had to take notes, analog notes, to organize the way you're recording data. I think that was like an interesting fact. And in the beginning, it was a little bit like Zen Buddhism, because I didn't have the recorder. So I spent like 6 hours programming, copying programs from magazines and stuff like that, show to all of my family, and then I had to turn it off and I lose it all because there's no way to record. So that's cassette recorder. I still have it up until today. The computer I don't have anymore, but the tape recorder was very precious to me. Okay, now I put here a little bit of like a landscape of what happened in my career, both academical and professional, with some timelines here so you understand. So right now I'm at LoadSmart with you guys. It's 2025. Going back in the professional career, I was in New York working for Work & Co., which it's like a digital company, a design studio / software development company. And they did mobile and web apps, but they were emphasizing the design of those apps. Prior to that, I worked in a research center, so it was a completely different dynamics. It was a group of 16 people in Brazil, and we were focused initially on oil and gas industry. All of them had at least master degrees. Many of them already had PhD or were doing a PhD. So they were researchers, and we did patents and we did research applied to oil and gas and later to other areas as well. I'll talk more about this. Before that, I worked at Global.com, where I met Gustavo Barbosa, which many of you know. It's the person who hired me at LoadSmart. And Global.com was a big news company in Brazil. It still exists. It's still there. It was a cradle for hackers in a good sense, because it hired very skillful people from many places. And we do have some members or former members of Global.com. Rodrigo Machado it's an example. Vinicius is another example. He worked with me. Yeah, Vinicius, thank you. He worked with me there at the same time. Machado, no, we were replacement Rodrigos. I left and he joined Global.com. Before that, I worked at HI Tecnologia, which is a industrial automation company. I'll give some examples there. And prior to that, I worked on a tiny little company, 6 people, called GPR Systems. And I will give some concrete examples there. But in parallel to my professional career, as soon as I finished my undergraduate course, I took one decision. And disclaimer, I'm not saying that you should do this. There's not a single career path, and there's no right or wrong career path. I'm just describing what I did and the pros and cons of what I did. Close disclaimer. So I decided to continue in academia after I graduated. So I engaged immediately into a master's course. But I knew that people that were full-time doing academical research, they were not as well compensated as people in the market, in the industry, in the software industry. So I decided to live this dual life. So I negotiated at the time at GPR to stay there half of the time, and the other half of the time I would have clearance to pursue my academical goals. So I was doing these things in parallel, and I did then for the first, oh, sorry, let me go back here. I did that for maybe the first 10 years or more of my career, actually more, because I started in 1996 and I stopped it only in 2012. So I was doing these things in parallel. So there will be some examples of stuff that I did in academia and some examples that stuff I did professionally. There is a third avenue, which is the open source avenue. In the midst of all of that, I engage with the open source free software community. And then I started contributing in some ways, some as coding, some as a developer advocate, broadcasting technologies, giving talks. And I will also give some examples about that. But this is the main landscape. I'm still studying and teaching. So when I joined LoadSmart in 2022, I was enrolled in an MIT course for data science to brush up my data science skills. And it was a very hard period for me because I was accumulating the tasks for a course at MIT with my new position as a director here at LoadSmart. So very busy times, I tell you that. And in August, I'm teaching a course for non-engineers about AI and data science for PUC in Rio de Janeiro, Brazil. It's a remote course. I'm giving a module there. Cool. So now I will go back to the chronological timeline. And I go back to 1992. So I just entered Unicamp, the Institute of Computing. I'm doing an undergraduate course in computer engineering, which at the time was a new profession. So in 1992, computer engineering was being defined. It was something kind of no one has kind of done before of sorts. We had other roles in informatics, but computer engineering trying to combine and create a professional that had traditional engineering skills, calculus, physics, chemistry, together with computer science skills, algorithms, data structures, a little bit of AI as well. These were computers that we were using. And as an anecdote, sometimes we're developing, this is on the left is Solution 16, which is an Intel 8088 CPU running at 4.77 megahertz. RAM could be from between 128 to 640 kilobytes, not much, but it's already had some had hard disk drives, not all of them, but some had hard disk drives that we could save. And we had floppy disks. So in this case, on the left, we have a Solution 16 that we gave it a nickname Pollution 16, because occasionally it would chew up your 5 1/4 floppy disk. So imagine you spend the nights doing your projects, then you go to save the projects, and then it chew up your floppy disk. And then you have to invite the professor to see the demonstration in the classroom, and that happened a couple of times Otherwise, you have to code it all over again because you're going to lose all your work. Different times, challenging times. Another cool aspect of the experience, I'm freshman at Unicamp, and people in post-graduation, people that were doing masters and PhDs, they had access to better computers. So these were Sun Spark workstations. They were much more powerful. You can see for like the processor speed here and amount of memory they had, and they had hard disks. And one way to have access to those computers was to simply engage in scientific initiation or participate of a group of research. So that's what I did. I engaged early with those groups to have access to those machines. They were running a version of Unix called Sun OS. And at the time, we had many flavors of Unix. SCO, Sun OX, AIX from IBM, and many others. Around the next year, we had the privilege from being this academical space to see the World Wide Web being born and use the very first browser, which was Mosaic, created by Mark Andreessen and Eric Bina. They were from the National Supercomputing Center, and they created this browser for you to see hypertext across the internet. So it was like a tool to explore the artifacts that Tim Berners-Lee created at CERN. During my time as an undergraduate student, I decided to start doing some tools for my teachers. So I was watching computer architecture classes, and MIPS, very good, yes. And my professor was using transparencies, using an overhead projector. And it was very hard to follow when he was saying, hey, do you see this line from the unit logic and the arithmetic and logic unit going all the way towards the register, blah, blah, blah. It was very easy to get lost. So I created this short program that he could use to highlight, given an architecture diagram. So we were able kind of to follow. I didn't know at that time, but many years later, this professor became director of computer engineering course in another university called PUC Campinas. And because of the rapport and the relationship that I developed with him, he invited me to become a teacher many years later. So this was like, in retrospect, I can see that maybe this gift that I gave to him may have contributed for me to getting a job years later. Another of these initiatives was doing a course on image processing with Professor Alexandre Falcão. He was teaching voxels, which is like pixels in 3 dimensions. And how do you get images in 3 dimensions and you manipulate those images? There are a bunch of interesting problems in terms of what you're seeing, there's occlusion, how do you rotate those things in 3D space, and etc. And then I decided to create for him, sorry about the resolution of the image, but this tiny little tool. He was working all with C. So anything you wanted to do with the tooling he offered to the students was command line, and you had to write tiny little C programs. But with this Python shell, developing 1995, it was possible to interface with his libraries and then be more interactive and make the classes more exciting. Another thing that was a positive of attending a university such as Unicamp that has more international projection was that some people some foreign professors or technologists would come to teach us courses. So I was lucky to attend a course with Richard Stallman. Richard Stallman is a very polemic figure. My first contact with him was at Unicamp. He gave us a course about the GCC, the GNU compiler chain, which is the C compiler from the GNU project. It was a very interesting course, very hard, but very interesting. And it was funny that during the course, he was with his flute. He usually played the flute in between classes. And then he decides to go to the bathroom, but he was wearing a microphone, a portable microphone, and he doesn't turn it off. Until today, I don't know if it was intentional or if it was an accident, but we could hear Richard Stallman doing everything in the bathroom. Kind of a surreal experience. This second guy here, I don't know if anybody will know him. I only recognize him because he gave us a course as well. This guy is called Christian Nigard, and he's one of the fathers of object orientation, together with Alan Kay. This guy created a language called Simula. He's from Norway, and he invented inheritance in object orientation. So he created the concept of, oh, one object can inherit properties from another object. And his goal at the time with object orientation was to do simulation in physics. So that's why he pursued object orientation. This other guy is even more famous and with great impact. He created LaTeX, and he created the Paxos algorithm, which is the one behind any distributed system nowadays. He's Leslie Lamport. He gave a couple of talks for us at the time, some about distributed systems, some about the LaTeX system created by Donald. LaTeX was created by him, but it was a layer on top of TeX created by Donald Knuth, which is another very important person in computing, modern computing of sorts. And Christian Nigard, and this may be one of mistakes in my career, Christian Nigard invited me to do a PhD with him at the time. And I decided not to do for many reasons. One of them, that I was scared. Another one, I was not fully sold on pursuing an academical career. Maybe my career would be completely different, but I refused. And I had a little bit of regret of not pursuing that today. 1994, for people in Brazil, they may have heard of INPE, the National Institute for Spatial Research. It's our NASA. And Unicamp has a close partnership with that institute. And I was able to work with geographical information systems with INPE. Spring was a system created by Gilberto Câmara in INPE. It became very popular at the time. Nowadays, we have hundreds of GIS tools, but in 1994, Spring had some noise in that space. And this will be relevant when I talk about my master's later in the game. 1996, I leave university. I start work in the industry. I got my first job. I'm still doing my last year as an undergraduate at Unicamp. So one of the professors at Unicamp invited me to work in his company. He left a big company in Brazil called Embratel, which was the national state company for telecommunications. And he created a tiny little company to explore a new market, which was called X25. X25 was a network before the internet for businesses. So you could buy access to X25 network and interconnect your business. And then I joined Franzin at GPR to develop products for this communications network. And in 1996, Windows 95 was recently launched. So the task that I was given was to develop a device driver for the products that GPR already had to make their software to work on Windows 95. So I started working with device drivers, which was completely new to me. And my very first program in a device driver was to boot Windows and see it freeze. And then I knew I was successful. Today, people may call that arguable because Windows 95 froze on itself occasionally. But in that case, it was fun that we froze it intentionally because we put a device driver, a VXD, virtual device driver. It was a specific bit of technology because the prior versions of Windows 3.11, for example, Windows for Workgroups, it was a thin layer on top of Microsoft DOS. So Microsoft DOS was the operation system, and Windows was simply a program running on top of the operating system DOS. But Windows 95 was a full-blown operating system. So it required a completely new set of device drivers. And it was very tough because there was not much documentation. And it was very complex because we had to develop an application that runs in user space. And then we had to develop the device driver that runs in kernel space. And the Intel architecture, there is some rules for code in kernel space. And in the middle, we don't have a direct connection. The Windows operating system is in between. So the application gives data to Windows, and Windows gives data to you. And what I found out was that some reserved fields in structs were not reserved. We're supposed to use them. And some other fields that we were supposed to use in the documentation, they were actually reserved. So the official documentation was wrong, and it was sabotaging the success of my initiative. So I was in panic for a month because I was not making any progress until I bought a book from a former Microsoft employee. And then he explicitly said this mismatch between reserved and some fields. And then I, in a couple of weeks, finished porting the device driver. The X25 network was a little different than what we have in the internet today. It has its given structure. And what we did, we developed a network interface card. So we didn't fabricate. We had another company fabricating the network interface card, but we developed all the software that was using the interface card. And this is like, so I apologize for the English speakers. This I found in the Wayback Machine, the Internet Archive, the website of the company I worked for. I actually did the logo for them because they didn't have a marketing department. So I created the logo on the top using kind of paintbrush and other low quality tools. And that remained the logo for the company for many years. But all the products at the company at that time were things that we take for granted today, like a terminal or file transfer software, like an FTP thing that you could do through X25 network, or a remote control like TeamViewer. And these things were interesting at the time because in DOS, the screen was text-based. The majority of the programs use a region of the memory that was the screen. So we were able to capture everything that any program was doing by simply capturing the video memory region. And then we transferred the video memory region from one computer to the other. And then in the other computer, you had exactly what the first computer was seeing. And we could do the same thing with the keyboard. We could interrupt and capture the keys and send the keys across to another computer. So we could keep two computers in sync using the X25 network. And then comes the internet. And the internet is the first disruption. It made GPR business obsolete because the internet was cheaper than X25 network. The internet had competition for programs such as terminals and file transfers and whatnot. So overnight, the company had to reinvent itself and pursue other projects. So we started to doing anything that would bring money to the company. So for example, one company came to us and said, I want a program that looks like a pager. Notice, we're talking 1997 here. It's way before iPhone. Mobile computing, it's in infancy, but pagers were something very familiar. And what they wanted was a pager-like. So the IT of the company wanted to put a pager in every screen in a modal fashion. That means you couldn't do anything with your computer until you acknowledge that you received that message. So IT could send a message to all employees, such as upgrade this particular software or take notice of the security policy, whatever. So this program was kind of interesting because it was an unconventional UI at the time. So in order to create that thing with the shape of a pager, I had, and with buttons, that is an elliptical button, I had to use the formula of an ellipse to capture clicks on this area. I had to get the coordinates of this boundary to record the rectangle that I was drawing onto the screen. So it was very low level to be able to accomplish something as simple as this kind of look and feel. Another very odd project that we did was the emulator for telex machines. So telex was a completely separate network, and it was ancient technology. Even in 1999, it was already ancient. Think that in 2000, we had Matrix released in the screen, right? 1999, people were using telex. Why, God, why? Because the telex network was used for ships that were coming to shore and for some law firms and courts of law, because the telex network had a date and time that couldn't be faked. And the internet, you could very easily fake the date and time of receiving or sending a message. But in telex, you could not fake that because it was centralized. So what Embratel, the company behind X25, did was, hey, let's create something that we can merge telex and X25, so we can still sell X25 a little bit longer. And then we developed software to enable telex to be glued with the X25 network. And now an interesting anecdote. The project had an 8-month horizon, but negotiations with Embratel were tough. They took 5 months. When we finally finished up negotiations, Embratel said, you only have 3 months to develop now. And we said, but we need 8. So we had to do the work of 8 months in 3 months, and everybody got sick because we had to work like nonstop for 3 months. I had to pause my master's degree at the time, and I was kicked out of master's degree because I was about to defend my thesis. But because I was full-time working on this, I lost the schedule. So I was kicked out, and then I had to enroll again after this project concluded, and then I was able to defend and get my degree, my master's degree in computing. Speaking of master's degree in computing, my thesis was about computational reflection, which I believe not a lot of people know what it means. We do know what is introspection. We do know a little bit about reflection, but what was being discussed in the academical space for reflection? So my thesis was joint work with a guy called Alexandre Oliva, and he changed the Java virtual machine to allow you to intercept every method call between any object. So he created that mechanism in the JVM. And what I did was create the other layer or of what can you do once you have that interception mechanism. And this thing here, it's basically a log that you can plug into a running program. So you have something that is already running in the JVM, you plug this software, and then you can take possession, like a demon or an evil spirit, of any object, all of them or a single specific object. And once you take possession of these objects, you can see all the messages they are exchanging, and you can change the outcomes. So you can just observe, or you can change a result, or you can do anything you want there. It's super slow, especially if you intercept everything. But it was pretty interesting, and we proved that we could do debugging, we could do persistence, we could do a lot of non-functional requirements using that kind of mechanism. I can talk more about this offline or in a part 2 some other day. I mentioned to you guys that I also started putting my feet in the open source waters. And one contribution I did in 2001 was to translate the Python tutorial by Guido von Rossum to Portuguese. And that became my entry point to the Brazilian community of Python. So I translated the tutorial. It took me a whole week to fully translate. And then I sent it to the Python international community. And Guido was very courteous to send me an email. And this is what I capture here. I already shared this a couple of times because it's kind of memorabilia, trophy of honor for me, for him acknowledging and putting the link to my translation in the official Python pages, in the non-English documentation. And nowadays, we have a community responsible for keeping the translation alive and up to date. But at the time, I did it on my own. This was another work I did in academical space, which was a system to marry geographical information systems technology with precision farming. So what I was doing here was using a technique, and maybe this was my first step towards the data science career later in the game as well. So this is NDVI. What is NDVI? NDVI is for you to use satellite signals and measure the reflected light from the surface of the Earth, and you were doing the difference between the near infrared and the visible red, because water, ground, and vegetation reflect differently these two bands of the spectrum. Water will diffract both of them, soil will reflect both of them, but vegetation will reflect one and absorb the other in different degrees. So because of that property, we can measure how healthy the vegetation is, and then you can use that to calibrate precision farming, identify pests and stuff like that. So it's pretty cool. We published a couple of articles in there. And the technique that I did to do this is captured on the screen, where I use a little bit of my knowledge from computer graphics, not just image processing, but computer graphics. I use a flooding algorithm. So I needed to combine two things. I needed to combine a raster image, which is a bunch of like pixels, with a vector image, which is coordinates. and then I need to extract what's within the boundary of the vector and process just that. So this is how it was done. And in 2005, I organized the first encounter meetup for Python in Brazil, which became PyCon Brazil 0. At the time, this was the invitation I organized within Unicamp, and this was the group of people that helped me. They were speakers, invited speakers. I personally picked them up at the airport in Campinas, brought them. I was Uber driver at the time as well. And this is people leaving the for lunch on the very first day. You may recognize some people here. Luciano Ramalho is pretty well known in the community. He has a great book for Python, which is called Fluent Python. I don't receive anything to recommend, but it's a pretty good book. One of my kind of favorite books in that space. We have Gustavo Niemeyer beside me here, working today for Canonical, famous from Connectiva. He is the guy who created GeoHash. So if you ever heard about GeoHash, and we know some of you guys use it today, the guy who created geohashing is this guy. Very good. And then you'll see like a series of pictures here, just for you to see the growth of the community. So first year, it's 90 people, which was a pretty good result for our very first encounter. And then you can see the community growing year by year. Second year was in Distrito Federal, which is the capital, political capital of Brazil as well. And then in Joinville, no Paraná, maybe even some of you are in those pictures. I don't know. I have a bunch of those. I'm always here with the arrow, so you can find me more easily, just because of the context of today. You see Ramalho here, Eric Andrei, also famous in the Plone community, Werneck, and many others. Dornelis Tremea. So the Dornelis Tremea Prize, it's because of this guy. Big friend, unfortunately passed away very young. Tatiana was is still here. She's working for Astronomer. I brought her to give a talk to the data engineering and data enablement team not long ago. And in 2007, we created the Association Python Brazil. Why? Because we needed a juridical figure to be responsible for organizing the conference. It was very hard to organize a conference as a personal and without being a company or just entity representing the conference. So we created the Association Python Brazil to sponsor conferences, and later it took more other roles. And then Rio de Janeiro, the city that I was born, in 2008. 2013, another pivotal moment. Vinicius, I don't know if you were in that photo, but it was the first Python Nordeste conference. Or maybe we have other people here at LoadSmart that participated. You're not in that one? Shame on you, man. It was super cool. The usual suspects were in there. I gave a talk. This guy here now is working for Anthropic, Chiquinho. He was with me at Global.com, very talented guy, but there are many others in there. Then, now let's switch gears. Oh, that's cool. And then in 2008, I left GPR Systems and went to work for industrial automation. What do you see on this picture? Every tiny little dot here, it's one of these machines. It's a pump. Oh, you couldn't go to Fortaleza, Vinicius. That's a shame, man. But that's cool. You still play a big role in the Python community in Brazil. And I'm glad you're together here today. So this actually, I don't know if this one is in Rio Grande do Norte or in Bahia. but we have both in Rio Grande do Norte and in Bahia, Alagoinhas, in Rio Grande do Norte, we have major fields on land to harvest oil. And HI Tecnologia, the company I was working for, it did software. Cool. So, Mayara, I've been to Alagoinhas a couple of times because of these. And so HI Tecnologia was one of very exciting. Yeah, indeed, it's the biggest. So in HI Tecnologia, we did the whole spectrum in computer engineering. We design hardware, we build hardware, we design software at all the levels: operating system, device driver, applications, telecommunications, and we deployed those things in place. So it was great to work on that company because they had that experience of doing everything. In particularly, this equipment that they still sell, it was me who gave it the name P7C, because these types of computers, they are usually called PLC, Programmable Logic Controller, and P7C was a play on words. An L turned around becomes like the model, and they liked that. And do you have something to say, Vinicius? No? Okay, cool. So anyway, so this is a full-blown computer. The biggest difference is that instead of a human interacting with this computer, you have machines interacting with the computer. So you have a bunch of entries here. Some are digital, some are analog, but they control actuators, motors, sensors, and everything that this computer does needs to happen within 1 millisecond, because if it's more than 1 millisecond, you may lose a signal transition. So this is where my table while I was working for HI Tecnologia. And at this time, this equipment here, I was developing a device driver for a file allocation table, a FAT system, so that the computer could have a file system. It took me 6 months to develop this device driver. This is an example of like more higher level software. This was a SCADA supervisory system where the people can kind of drag and drop and build the plants and the machinery they have, and they can associate with variables for the process they want to monitor. So it's kind of a data dog for the industry. And this particular one, I was working on a compiler, and this compiler was very interesting because it was not compiling text into binary. It was compiling a diagram into a binary. So what you're seeing on the right is a visual language. It's called sequential flowchart. This visual language has these components, which is states, transition of states, and special actions. These special actions can be start a timer, end a timer, turn something on, turn something off. This double line here means do these things in parallel. This double line here means synchronize these two parallel flows into a single flow. In one of these boxes, you can have code. So in one of these boxes, you can have a Pascal-like code. So it was a mixture of diagram and Pascal, and we had to do a double translation. First, we need to translate to another language called ladder, which is what you see here on the right, which is another visual language. And then we had also to translate ladder into a binary. That's a very challenging project, but also very exciting. And when I was in my undergraduate course, I felt that I would never work with compilers. And in my career, I had to work with compilers 3 times. This is the second time. Now I jump to 2013. I'm at global.com. Vinicius is my witness here. there was a period of overlap there. And I developed together with two colleagues, Tatiana and Icaro, and Ellison, I guess, knows Icaro as well. Uh, we developed this RESTful API for the semantic web for global.com. I know we're kind of almost out of time. Yeah, exactly. So Brainiac is still in use at Global today. I talked to Cabra. Vinicius may know Cabra, but I talked to him a couple of weeks ago, and he said Brainiac changed a lot, but it's still there. But anyway, Brainiac was an API to do something that today is becoming known as polyglot persistence. At the time, it didn't have a name, but it means we have multiple databases behind a RESTful API, and then we can offer that to applications. But it was more bold than that. Danilo Bardusco, our director at the time, wanted us to implement the vision of Roy Fielding from his dissertation thesis about hate OAS. And it was meant that these APIs are so self-explanatory that a generic application can navigate the API and use the API even not knowing the API beforehand. I capture a bunch of points from Roy Field's dissertation here. We don't have time to go in detail over these, but this should be enough to show you how advanced and way ahead of time they were in the year 2000. Some things that he mentions here are still relevant 25 years after that. Jeff Bezos shared this in 2012, threatening all his employees that if you don't implement RESTful APIs, you'll be fired. What a nice touch from a CEO. Anyway, so I will skip these because of time, but basically they were showing how an editor was producing news and doing manual annotation of concepts, such as a particular soccer team, a particular person, and then how we materialize that in the web later. And then that infrastructure was allowing us to create a page for everything that talks about that person or everything that talks about that particular entity. And this was the hyper map of navigation from our API. You could navigate in our API, understanding the endpoints, understanding the schemas. They were all self-describing. So you could create an application, a generic CRUD application that would plug in any of our APIs and would be able to edit the content of those APIs. So develop once the CRUDs and later just develop your APIs if you follow these guidelines. So this was like the API saying, hey, I have a get method to offer you a class entity, and here's the schema of that class entity, and so forth. This was you using the API to get a concrete instance, and then it's like hyper documentation of that instance. And this is an example of the app that was generic, the CRUD generic app that plugged into an API and then rendered editing forms just based on the self-description of that API. And you can see that we developed this in 2013, but it's still some modules are still relevant today. We didn't have a sync at the time, so we had to do some tricks with Tornado and Greenlets to make it happen. This is my team that we work together to make Brainiac come to reality. I worked on hackathons. This was another interesting project to summarize news so that you can shrink a bit of news. And this is the hackathon making of. So we had 24 hours. The whiteboard, it's the group deciding what we're going to implement. It was half software engineer, half machine learning, half data science work. And then I switched to EMC. And at EMC, I started like a more managerial path. So you see me wearing a tie and going to a conference and doing some other things. I will skip these because we're out of time. These were like other projects. It can be for like part 2. We are out of time. I just want to thank you for like showing up and staying up to the end. You can reach out to me offline if you have like any questions. If you have feedback of stuff that you enjoyed, stuff that you didn't enjoy, please give me the feedback so we can improve on this. I'm planning to show a version of this in Python Brazil this year if my proposal gets accepted. Thank you, folks.